Is audible, right? Are you able to see
Ma'am.
PPT?
Yes, ma'am.
PPT also you are able to see?
Yes, ma'am.
Okay. So now, what just we'll try to recollect what we have done in the last class. I think we discussed characteristics of laser, right? So what are the 4 important characteristics of laser?
Directionality,
Yes.
monochromicity, high intensity,
Yes.
and coherence.
Yeah, good. So it has got 4 properties. One is directionality. So first one is directionality, monochromicity, highly intense, and coherence. What do you mean by directionality? Well, all beams of laser light, they are going to travel in single direction. What is monochromicity? Where it exhibits single wavelength or line width is very, very small. Highly intense means number of photons emitted per unit area per second. They are large. And coherent means where if you take two light beams of laser light, they are going to have either zero or constant phase difference between them. Okay, so these are the characteristics of laser. I think after that we have taken some definitions. So what is that first definition we have taken? I think we have taken first definition is absorption. What is absorption, students? We said that if we take two energy states, E1 and E2, okay, generally if we don't supply any energy, all the atoms are electrons, they are present in the ground state. And suppose if I take one atom in the ground state and if I expose it to photon, and what should be the energy of photon? Energy of photon, it should be equal to h nu is equal to E2 minus E1. Then what this atom or electron will do, it will absorb that energy and it will get excited to higher state. So that excitation of electron from lower state to higher state by supplying energy in the form of photon is nothing but absorption. Okay. Then after that, I think we have taken spontaneous emission. We know that after absorption, our atom or electron, it is in the excited state. Now we have to make this atom come down after its lifetime. We have defined lifetime. Okay, so what is lifetime, students? Lifetime is duration of time spent by an atom in an excited state. So every energy state will have its lifetime. After lifetime, what happens to that atom or electron? It will lose energy and it will come down. So here after absorption, our atom or electron, it is in excited state. So it will stay there for its lifetime. After its lifetime, on its own means without supplying any external energy, this atom or electron, it will come down. It will get de-excited from higher state to lower state. And when it get de-excites, it emits a photon. And what is the energy of that photon? H nu is equal to E2 minus E1. So in a spontaneous emission, per emission, we are able to get one photon. But ultimately, what type of radiation will get in spontaneous emission? We are going to get, what is that radiation? I think yesterday I told you it is non-directional and polychromatic, incoherent, as well as less intense beam. But main phenomena that will give us laser light is stimulated emission. So emission means de-excitation of atom or electron from higher state to lower state. And what is stimulated? Where we are forcing atom in the excited state to come down before its lifetime. So we are pushing this atom down before its lifetime. For that, what we are doing, we are making a photon whose energy is equal to, again, h nu is equal to E2 minus E1 to fall on it. Then when it comes down, there are two photons. One is your incident photon, which is pushing it down. And other one is because of de-excitation from higher state to lower state. So per emission, how many? Two photons. And if four atoms come down, so 4 into 8, 8 photons. So number of photons are more. And all these photons, they travel, when they are traveling, they maintain same phase. So that's why we are saying that what type of radiation will get out of stimulated emission, we are going to get directional, right, monochromatic having single wavelength, then coherent as well as highly intense beam, that is nothing but laser light. Okay, so we are going to get laser light because of this emission. But I told you one point that even spontaneous and absorption, they are going to help us to get laser light. That we'll discuss when we go for any laser system. Okay, then next definition, I think we have taken all these differences. Then metastable state. What is metastable state? We said that if we take any material, in that material will have one ground state and there are many excited states. So out of all those excited states, there exists one excited state whose lifetime is long. So excited state which has got long lifetime, it is called as metastable state. Okay, students. Then after that, I think we have taken this why. So why this metastable state has long lifetime? Because we have taken Heisenberg's uncertainty principle. From Heisenberg's uncertainty principle, delta T is inversely proportional to delta E. It means that lifetime is inversely proportional to energy level width. And we know that for metastable state, lifetime is long. So that's why its energy level width is small. Okay. Then after that, we have taken population. What is population of an energy level? It is generally denoted by N, and population it is given by how many number of atoms or electrons are present per unit volume. Okay. And this is very important formula. N is population of an energy state E. N naught is population of ground state, and K is Boltzmann constant, T is temperature. And this population and energy level, they are inversely proportional to each other. So that's why we'll observe that population, it will be maximum in ground state. And when we go up slowly, when we go to higher energy state, its population is going to decrease exponentially. Okay. After that, we have taken one very important term known as population inversion. So what is population inversion? Generally under normal condition. What is normal condition? When we don't supply any energy. So when we are not supplying any external energy, population of lower state will be higher than population of higher state. Generally, population of lower state will be higher than population of sorry, population of lower state will be larger than population of higher state. But if I supply energy and if I make population of higher state more than lower state, then that particular condition it is called as population inversion, and it is also called as inverted population. Okay, students. And how we can achieve population inversion, we have seen in this three energy level diagram. So generally, if we take this three energy level diagram, in this we said that if we take this, generally we have taken three energy levels. In the three energy levels, this E1 is ground state. So this is our ground state. So this is our ground state, and we said that for ground state, lifetime is long as we don't supply any
Unlimited.
energy. Yes. And E2, we called it as metastable state. What is metastable state? Which has got long lifetime, right?
Yes.
E3 is higher excited state whose lifetime is very less. Okay, generally when we don't supply any energy, more number of atoms will be present in ground, and as energy state increases, what happens to population? It keeps on decreasing. So under normal condition, when we are not supplying any energy, and when we take their energies as E1 less than E2 less than E3, how will be the population? Population will be greater in ground state, and then in first excited state, and then in second excited state. But if I supply energy to all the atoms which are present in the ground state, what happens to these atoms? They'll get excited to both E2 and E3. All the atoms, some of them will go to E2, some of them will go to E3. But atoms which have gone to E3 within short time, within few milliseconds, they'll get de-excited to E2 as well as E1. Why? Because its lifetime is very less. So within short time, they'll get de-excited. But atoms which have gone to E2, they won't come down fast, they won't lose their energy fast because its lifetime is more. So it will try to retain those atoms for more time. So here in E2, we have observed that first atoms, they have gone from E1 to E2, and some of them have been added from E3 to E2. So as you can see, a stage will be reached where population of E2 will become more than E1. So here N2 is our metastable state. Population of N2 is becoming more than N1, and this condition is nothing but population inversion. And I gave you one point. Population inversion is always achieved in metastable state. Why it is always achieved in metastable state? Because of its long lifetime, because of its ability to hold atoms for more time. Okay, students. So after this, I think we have taken one more definition. What is the definition? I think we have discussed
Pumping.
about pumping, right? What is pumping, ma? We know that in order to achieve population inversion, first we have to excite atoms in the ground state to higher state, right? So for that we need to supply energy. So that process of supplying energy is nothing but pumping. I think yesterday I gave you various pumping methods. What are those various pumping methods? Optical pumping, electric discharge, atom-atom collision, direct conversion, chemical
Direct
reactions.
conversion,
Okay,
chemical
and
reactions.
depending upon see, we'll have different types of lasers. Different types of lasers, they are going to use different pumping methods. So in our syllabus, we have two lasers. One is ruby laser, other one is helium neon laser. There you will be able to understand this pumping method more when I discuss about those lasers. Okay. So after this, yes, Karthik, any doubts? You've raised your hand, Karthik.
No, ma'am, no.
No doubt, Karthik.
No doubt, no.
Okay, ma'am. So now our next topic is lasing action. Okay, just 1 second, students. Okay. Now, are you able to see this PPT, ma'am? Are you able to see this lasing action?
Yes,
Okay.
ma'am.
Now, what is lasing action? I'm going to draw one figure. I want all of you to draw in your books. Okay. Now, now just look at this figure and tell me what you are able to understand. Yes, what is happening here? So this process is lasing action. Now, what is that first figure, students? What is our first figure? What is this figure?
Stimulated emission.
Yes, what is stimulated emission? What is stimulated emission? After absorption, where is our atom? Atom is in the excited state. Okay. So in order to make this atom come to ground state, and I want to make it come to ground state before its lifetime. Okay, ma. Then I have to push it down now. In order to push it down, I'm supplying energy. What is, yes, what is that energy supplied? That energy is supplied in the form of a photon. Okay. And what is the energy of that photon? That energy should be equal to E2 minus E1. Okay. When this photon of energy equal to E2 minus E1, if it is incident on this atom in the excited state, then what happens to this atom? This atom is pushed down. It means that it is de-excited from E2 to E1. And we know that when an atom gets de-excited from higher state to lower state, it releases energy. And how much energy it will release? E2 minus E1. It means that per emission, in stimulated emission, how many photons are emitted? Two photons, 1 and 2. What is this first photon? This is our incident photon, which is pushing it down. And what is our second photon? Photon, because of de-excitation from E2 to E1. When it releases energy, it comes out in the form of photon. So when two atoms have come down, how many photons are emitted? Two photons. Now come to the second figure. In second figure, what is happening? These two photons, 1 and 2 are these photons which are emitted during this de-excitation. Now what these two photons are doing? Can anyone tell me what is happening in the second figure? Yes, ma'am. Yes. What is happening in the second figure? What happened? You're not able to understand what these two photons are doing. These two photons which are emitted here, what they are doing? Now these two photons, they are acting as stimulus energy. Stimulus means what? Stimulus means energy. Means what? Now these two photons, what they'll do? See, ma.
Okay, pushing them down.
Yeah, yes. See here, we have taken two energy states, right? E1 and E2. Just for our understanding, I have taken one atom. But will there be only one atom in excited state? There will be many atoms, right? There will be many excited atoms in E2. Okay. When one atom comes down because of stimulated emission, how many photons are emitted? Two photons are emitted. So what these two photons will do, they'll go and again they'll strike two excited atoms. When they go and strike two excited atoms, then what happens to these two atoms? They'll come down. And if they come down, how many photons are emitted? For this emission, two photons. For this emission, two photons. So total, how many? Four photons are emitted. So what these four photons will do? These four photons, they'll go and they'll fall on four more excited atoms and they'll make them come down. And when they come down, how many photons are emitted? Per emission, two. So total, how many photons? 8 photons
8,
are
ma'am.
emitted. So like this number of photons, they are going to multiply. There will be multiplication of photons. Lasing action is nothing but multiplication of photons. And how these photons are multiplied? Because of stimulated emission. So one stimulated emission is enough in order to get lot of photons. If I am able to make one atom come down by making one photon to fall on it, out of photons emitted during stimulated emission, I can get many number of photons. Okay, and this process it is called as lasing action. And we know that due to stimulated emission, whatever photons are emitted, all of them together, they are going to give us what type of light radiation? Laser. So how we are going to get laser light? Laser light is made up of many photons, and how we are going to get those photons? In order to get those photons, first I should achieve population inversion. What is population inversion? By making population in higher state more than lower state. And once I achieve population inversion, once I am able to get more number of excited atoms, I have to push all these atoms down by stimulated emission so that I can get many number of photons, and these photons together they are going to get laser light. And for that I need just one photon. In order to trigger this lasing action, I need only one photon, because this one photon, when it makes one atom come down, two photons, these two photons they'll make two more atoms to come down. So this process, actually this process, it is also called as avalanche effect. So what is avalanche effect? One photon is enough to trigger emission of large number of photons. So this is called as avalanche effect. I think those who have studied Zener diode, they have some understanding about this avalanche effect. This is CT. Okay. So are you able to understand what is lasing action, students? What is lasing action?
Multiplication of photons, ma'am.
Photons. Yes, multiplication of photons by stimulated emission. Right? And how we are getting that multiplication of photons?
By
If one
striking the photon.
if one stimulated emission takes place, then photons from that stimulated emission, they are going to make two more atoms come down, and again whatever photons are emitted, they will make some more excited atoms come down. Okay, so resulting in plenty of photons, and these photons together they are going to give laser light. Okay, so actually you can say that this is light amplification process. Lasing action, it is also called as light amplification. Other name for lasing action is light is getting amplified. What do you mean by light amplification? Where number of photons are getting multiplied. So this multiplication of photons is nothing but light amplification, and this light amplification is nothing but lasing action. I hope you have taken these two figures in your book, students. Yes, any doubts?
Yes, no, ma'am.
You have taken? Shall I wait or shall I go for next slide? Huh? Shall I go for next slide? 1 second. No? Yeah, next one. This is our topic, students. And this is very important topic. Block diagram of laser system. If you are able to understand, block diagram of laser system, then understanding any type of laser is very, very easy. Okay, I want you people to take this figure in your notes. All of you copy this figure in your notes. Then I will tell you what exactly is this block diagram. Okay, all of you copy this figure in your books.
మ్యామ్ స్లైడ్ సరిగ్గా కనిపించడం లేదు.
కనిపించట్లేదా అమ్మా? కనిపించాలి. వెయిట్. Now?
ఓకే మ్యామ్.
Okay. So all of you draw this figure in your notes. I hope you all are taking this figure in your notes. Now, after you take this figure, copy this in your notes. So did you finish copying this figure?
No,
Okay. See, you should be able to understand this block diagram. Because based on this block diagram only, we are going to discuss different types of lasers. Yeah, take this all, then you will have better understanding about this block diagram. So just to give you 2 minutes, then we'll start discussing about this. Once you are done, just let me know. Then we'll discuss about this. Finished now, students? Completed. Okay. So now we'll discuss about this. Now, listen here carefully, all of you. It's very important for you to understand. Okay, now. So if you take block diagram of laser system, any laser system, whether you take ruby laser, helium neon laser, or suppose nitrogen laser, carbon dioxide laser, any type of laser, it is going to consist of three main parts. So what are those three main parts? First part is active medium. So this is our first part, active medium. Okay. Then coming to second part. Second part is energy source. This is our second part, energy source. And what is the third part? The third part is this is resonance, not resonance, resonance cavity, or it is also called as optical resonator. Right. First, I'll tell you what is active medium. Are you able to see this active medium in this block diagram? This is our active medium. But what is active medium? Medium means material. Okay. So what type of material you are using in order to generate laser light? Suppose if I take ruby laser. In ruby laser, what is the material we are using in order to generate laser? Ruby rod, ruby crystal. Are you able to understand, students? Whereas suppose if I take helium neon laser. In helium neon laser, what type of material I am taking? It's a gas, which is combination of both helium and neon. Whereas if I take nitrogen gas laser, what is the material I am using? There also it is gas, which is nitrogen. So like that, depending upon what is the material you are selecting in order to produce laser light, that material it is called as active medium. And that active medium, it can be in many forms. As I have given you, it can be a solid material, it can be a liquid material, it can be gas, or even you can take your PN junction diode also in order to generate laser light. And what is the role played by active medium? Inside the active medium, we'll have different energy levels. So inside the active medium, we'll have different energy levels. And we know that once we have different energy levels, there will be one energy level, one excited state which has got longest lifetime. That one particular energy state is called as metastable state. And what is the use of metastable state? In metastable state, population inversion will be achieved. What is population inversion? What is population inversion?
Number of electrons more in first excited state, ma'am. Population
Not first excited state. What you have to remember is higher state.
Higher
So
state.
population of higher state will be more than lower state. Okay. And generally, where will achieve population inversion? In metastable state. Why in metastable state? Because it has its property of retaining atoms for more time. It won't make them come down faster. So it will retain them for more time. Are you able to understand, students? So, are you able to understand what is active medium? Active medium means material which you are choosing in order to achieve laser, in order to get laser light. And this active medium, it is going to be different for different types of lasers. If I take ruby laser, it will be a solid state material that is nothing but ruby rod. If it is a gas laser, so depending upon what type of gas laser you are taking, whether it is nitrogen gas laser, carbon dioxide gas laser, so we'll have, so what is the material you are selecting, and that material, it can be in many form. So it can be solid, liquid, gas, or even your diode. And what is present in this material? In this material, you will have different energy levels. In those energy levels, you will have ground state, okay? Then many excited states. Of those many excited states, there will be one excited state which has got long lifetime, and that excited state, it is called as metastable state. And what is the use of metastable state? We can achieve population inversion in metastable state. So this is about active medium. Now coming to second part. What is second part? So are you able to see this active medium? It is subjected to this energy source. See how population inversion is achieved. What is population inversion? Population first, I have population of lower state more than higher state under normal condition. What is normal condition? When we are not supplying any energy. Suppose this is N1 and if this is N2, generally N1 will be greater than N2 under normal condition when we are not supplying any energy. But if I supply energy, then what will happen? What will happen, students? Now atoms, they will get excited to higher state, and when they get excited to higher state, so what will happen now? Now this is N2 and this is N1. Now N2 will become greater than N1. So that is nothing but population inversion, and this N2 is actually metastable state. Okay, in this condition it is population inversion, where we are making population of higher state more than lower state. So are we able to achieve population inversion on its own? No, for that we are supplying energy. So we need to supply energy in order to excite atoms from lower state to higher state to achieve population inversion. And that process, what is it called? It is called pumping. So what this energy source will do? Energy source, it will provide necessary energy in order to achieve population inversion in metastable state. And here also, depending upon what type of laser we are taking, there are different pumping methods. I think I gave you various pumping methods in our previous topic: optical pumping, direct conversion, chemical reactions, and then atom-atom collision, electric discharge. So different lasers, they are going to have different pumping methods. So is this clear? Is the second part also clear to you all? Madhavendra.
Yes, ma'am.
Okay, now students, have you copied all this? Shall I erase this one? This side, left side, shall I erase?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, 1 second. Now, see here, ma. Because of this first part and second part, what we are able to achieve? What is my first part? First part is active medium. Active medium will have different materials, and this different materials will have different excited states. Okay. So as I told you, suppose this is E1 and this is E2 and this is E3. Okay, ma. And let us say that E2 is metastable state, right? And next, what we have energy source. I'm supplying energy. When I supplied energy, then what happens? Atoms, they will get excited here E1 as well as E2. But what will happen now? Population inversion will be achieved in metastable state. So you will have more number of excited atoms in E2. So we are able to achieve population inversion. So after we supply energy, we are able to achieve population inversion in metastable state. So what do you mean by population inversion? Where I am able to get many excited atoms. So this is population inversion where I have many excited atoms. Now once I get population inversion, in order to get laser light, what should I do? Students are able to understand question. Role of first part and second part is to get population inversion. What is population inversion? Where you will have many number of excited atoms in P2. But once we achieve population inversion, in order to get laser light, what we have to do? Amma, what we have to do? Are able to understand, students? Alright, we got population inversion, right? We have excited atoms now. How we'll get laser light? How we'll get laser light? How will get laser light? Is it not lasing action? What is lasing action? What is lasing action?
By supplying energy
Yeah,
again.
lasing action is making all these excited atoms come down before their lifetime by stimulated emission. I have to make these atoms come down by stimulated emission. Are you able to understand? Only if all these atoms come down by stimulated emission, then all these photons together, they are going to give laser light. So here lasing action should take place. What is lasing action? Suppose somehow I'm able to get one photon. This photon, when it goes and falls on one excited atom, how many photons are emitted? Two photons are
Two
emitted.
photons.
Now again, what these two photons will do? They'll go and fall on two more excited atoms and then make them come down. Now how many photons are emitted? Four photons. What these four photons will do? They'll go and fall on four more excited atoms. When they come down, how many? 8 photons. So like this process will continue and ultimately you get your laser light. But our question is, did you get this doubt? How I have to make these photons go and collide with these excited atoms? ఫోటాన్స్ ఉంటాయి సరే కానీ ఫోటాన్స్ అవి వెళ్ళి ఆ ఎక్సైటెడ్ ఆటమ్స్ తోనే వెళ్ళి స్ట్రైక్ అవ్వాలనేది ఏంటి దానికోసం వాట్ వీఆర్ డూయింగ్ ఆన్ ఐదర్ సైడ్ ఆఫ్ యాక్టివ్ మీడియం ఐఎమ్ అరేంజింగ్ టూ మిర్రర్స్ ఆర్ ఏబుల్ టు సీ దిస్ ఇస్ మిర్రర్ 1 and this is mirror 2 and this mirror onto the left side is total reflecting mirror and this mirror onto the right side of active medium, it is partially reflecting mirror. What do you mean by totally reflecting and partially reflecting? What do you mean by totally reflecting and partially reflecting? What ma? Totally reflecting means whatever light falls on it, it gets completely reflected back. So it has got 100% reflection. 100% reflection. But whereas if you take partially reflecting, it means that it's a partial reflector as well as transmitter. So it will allow part of light to reflect as well as part of light to transmit. It will allow some of the light to pass through it also. It's not 100% reflecting. Okay. So, but it will allow some of the light to pass through it. Are you able to understand? So, if this is 100% reflection, so it is around 95% reflection will be there. So, it will make 95% of light get reflected back, and then rest of the light it will allow to pass through it. So, that is called as partial reflector, and this is full reflector. So, what we are doing now, the active medium only. Okay, active medium ki on both sides I am arranging two mirrors. ఒక మిర్రర్ ఏమో ఫుల్లీ రిఫ్లెక్టింగ్, ఏ లైట్ దాని మీద పడ్డా ఇట్ విల్ గెట్ రిఫ్లెక్టెడ్ బ్యాక్. ఇంకో సైడ్ ఉన్న మిర్రర్ ఏమో పార్షియల్లీ రిఫ్లెక్టింగ్, అంటే మాక్సిమం ఇట్ విల్ అలౌ లైట్ టు రిఫ్లెక్ట్ బ్యాక్ బట్ ఇట్ విల్ అలౌ సమ్ ఆఫ్ ది లైట్ టు ట్రాన్స్మిట్ టు ఇట్. Now what is the role of these mirrors? Now these two mirrors, they will act as like as I told you, whatever photons are emitted, I have to make these photons go and strike these excited atoms. మన active medium లో ఏముంటది, we'll have lot of excited atoms. So here we have lot of excited atoms. So there are lot of excited atoms are present here. In metastable state, lot of excited atoms are present. Now I'm able to get one photon. Okay, but why is it like how I can make this photon go and strike this excited atom? For that, what I'll do, whatever photon is emitted, I'll make it go and strike this mirror. My photons, ఇప్పుడు కొన్ని photons ఉన్నాయనుకోండి, ఆ photons ఏం చేస్తాయి, if they are traveling along the axis of active medium, they'll go and strike this mirror. ఇప్పుడు this is just like bouncing a ball against the wall. If I throw one ball against the wall, then what happens to that ball? It bounces back with full force, right? Similarly, ఈ ఫోటాన్ వెళ్ళి ఈ మిర్రర్ మీద పడ్డది అనుకో, because this mirror is reflecting, what happens to this photon? This photon will get reflected back. Again this photon, it will travel like this, it goes and falls on this mirror, and this mirror is also reflecting. So again this mirror, it will make this photon go back with full force. So like this, these mirrors, these photons, what will happen? They'll suffer multiple reflections at these mirrors, and during their multiple reflections, they'll go and strike this excited atom. So when this photon goes and strikes this excited atom, it will make it lose energy. And if it makes it lose energy, how many photons are emitted? Two photons. The two photons mali in this time, if they are traveling in this direction, again they'll undergo reflection at these mirrors, and they'll go and strike two more excited atoms. Are you able to understand? See, simply we said that photons, stimulated emission jarugute, whatever photons are emitted, they'll go and they'll cause two more excited atoms to come down. But what is the guarantee that these two photons, they'll go and they strike these two atoms? For that, what we are doing, we are supplying extra energy to these photons. And how we are supplying extra energy is by making them get reflected at these mirrors. So ఇప్పుడు లైట్ ఉంది, ఈ లైట్ ఇక్కడ ఏమవుతుంది, ఫోటాన్స్ ఇట్లా బ్యాక్ అండ్ ఫోర్త్ రిఫ్లెక్ట్ అవుతా ఉంటాయి. అయినప్పుడు what they'll do, they'll keep on striking these excited atoms and they'll make them lose energy. So from photon multiplication will takes place, and once your photon grows in strength, from where it will come out? It will come out from the partially reflecting mirror, and this photon light, it is going to give us laser. Are you able to understand this? Any doubts? Ma, see, population inversion వచ్చింది మనకి. We have excited atoms in higher state. What is our next step? Now I have to gather photons in order to make these excited atoms come down. So for that, what I'll do, some photons, if I'm able to generate these photons, what they'll do, they'll undergo multiple reflections, back and forth reflections at these mirrors. ఒక ఫోటాన్ ఉందనుకో, ఇది పోయి ఈ మిర్రర్ మీద పడితే ఇది రిఫ్లెక్ట్ అయ్యి మళ్ళీ ఈ మిర్రర్ మీద పడుతుంది, ఈ మిర్రర్ మీద పడితే అది రిఫ్లెక్ట్ అయ్యి ఈ మిర్రర్ మీద పడుతుంది. ఆ ఫోటాన్ ఇలా రిఫ్లెక్ట్ అవుతున్నప్పుడు ఏమవుతుంది, యాక్టివ్ మీడియం లో ఉన్న ఎగ్జైటెడ్ ఆటమ్స్ దాన్ని స్ట్రైక్ చేస్తుంది. స్ట్రైక్ చేసినప్పుడు what will happen, this excited atom, it will lose energy. Then two more photons are emitted. Again, those two photons, they'll undergo multiple reflections at these mirrors, and they'll go and strike two more excited atoms and make them lose energy. Then four photons are emitted. Again, those four photons, when they'll go and strike these excited atoms, only if they suffer reflection at these mirrors. So what is the role played by these mirrors? These mirrors, they are going to make these photons activated, so that these activated photons, they'll go and strike those excited atoms and make them lose energy by stimulated emission, so that we get lot of photons, and ultimately we'll get our laser light from this partial reflector. Any doubts? Any doubts, students?
No, ma'am, no.
Okay, ma. So this is about laser system. Now after this, in our syllabus, we have two types of laser. So time is there for us to discuss the first type of laser.
3 minutes there, ma'am.
So in next class, I'll discuss those three lasers, two lasers. See here, this figure you just see. I think that will give you more understanding about this optical resonator. చూసారమ్మా, ఇది యాక్టివ్ మీడియం, ఇది మనది యాక్టివ్ మీడియం. ఇక్కడ ఒక మిర్రర్ పెట్టాను, ఇక్కడ ఒక మిర్రర్ పెట్టాను. ఆ మిర్రర్ లో ఈ సైడ్ ఉన్నది 100% రిఫ్లెక్టర్, ఇక్కడ సైడ్ ఉన్నది 99% రిఫ్లెక్టర్. ఇవేమో మన ఫోటాన్స్. ఈ ఫోటాన్స్ ఏమవుతాయి, ఈ ఫోటాన్ ఇటు వెళ్ళి ఈ మిర్రర్ మీద పడితే బ్యాక్ వస్తుంది, ఈ మిర్రర్ మీద పడితే బ్యాక్ వస్తుంది. So because of back and forth reflections, they are moving like this, and here we'll have our excited atoms. So when these photons are getting reflected by these mirrors, inside the active medium we'll have excited atoms, and these photons, they'll go and strike these excited atoms, making them lose energy, so that we'll have more photons emitted. And once these photons are more in number, from where they'll come out? They'll come out from this partially reflecting mirror, and these photons together, they are going to give us laser light. So this process is nothing but light amplification by stimulated emission. I hope now you are able to understand that abbreviation. Are you able to understand that abbreviation? Okay, by stimulated emission, we are amplifying light. What do you mean by amplification of light? Where you are able to get multiple of photons, okay, by making this chain process of stimulated emission. Okay, right, students? So this is about our laser system. Now just have glance, all of you have glance at this PPT. I'm just showing you types of lasers. Suppose if you take solid state laser ante entamma, where active medium is solid material. Okay, so what are the materials you'll use? One is ruby laser. Ruby laser lo will make use of ruby rod. Then I have neodymium YAG laser. What is YAG? YAG, the full form is yttrium aluminium garnet. So you'll have neodymium YAG laser. In that, what is the solid material you are using? This material you are using. And if I go for gas laser low, you'll have many types. So what is the active medium you are using? Gas. And what are the gases which can use as active medium? So argon, krypton, xenon, carbon dioxide, nitrogen. So you can make use of all these gases. Then you will have liquid laser also. In liquid laser low, what type of liquid we use as active medium? As you can see, rhodamine 6G. It's a liquid suspension which is used as active medium in order to get laser light. Okay, students. So some more I can show you. So just see excimer lasers. Excimer is combination of two terms. One is excited, another one is dimer. Dimer means you can take it as where you have two atoms in a gas. Suppose if you take chlorine, two chlorine atoms come together to form chlorine molecule. So these are all dimer gases. Okay, so from those reactive gases, we are able to get laser light also. And then what are semiconductor lasers? In semiconductor lasers, I'll make use of PN junction diode as active medium. So what I'm trying to say here is depending upon what type of laser you are using. See here, so you'll have different types of lasers based on what type of active medium you are using. And that active medium, it can be gas, liquid, or any other material, any matter system. Okay, students, I hope you are able to understand. Okay, so these are all applications we'll discuss. So as I'm telling you, next class, I'll discuss about
Maths, ma'am. Maths.
Uchara, sir, Uchara.
Rather than-
Okay, so I think I'll end my class right now. So start your preparation. I'm going to end this class. Okay, students, all the best. Don't waste time.